Hello class, this standard is called INTEGRALS.4, and in the previous standards we just looked at the basic methods of integration. So we did the regular antiderivative, we've done it for trigonometric functions, and then the last one that we just did was something called U substitution, when you couldn't do integration because there was a function within a function. But these particular integrations there's two variables, so a y and an x, and they're on the same side. The way to solve it is called separation of variables. The process is a little bit long, so what happens is, or what we're going to end up doing is only being able to do 2 sample problems, so you could do some more in class. But again, this is called separation of variables, and the reason why you have to do it, as if you notice the format, there's a dy dx, so there's 2 variables, and they have a y and x on the same side. The very first step we're going to do is very similar to what we had done previously. I need to separate these variables. So I need to get the y's on one side, I need to get the x's on the other side. So what I'm going to do, first of all, is I'm going to multiply dx on both sides. By doing that, I will get dy equal to y to the third x minus squared dx. The only problem now is that the y needs to be on the other side. So I'm going to divide both sides by y to the third. So now you can see that both of the y's are on the same side, both of the x's are on the other side. Now that that's possible, now I can integrate to both sides. In the past I can't integrate because y and x's were on separate sides, so now I'm going to integrate. So I'll take my integration sign and apply it to both sides. You may not know the antiderivative of 1 over y to the third, but you should know by now that that means the exact same as y to the negative 3. So knowing that, and you don't have to write this down, but knowing that 1 over y to the third is the same thing as y to the negative 3, you should know its antiderivative is going to be raising 1, so y to the negative 2, and dividing by it. So my new left side will look like negative 1/2 y to negative 2 plus c. On the right side, the antiderivative of x is half x squared, and the antiderivative of 2 is 2x, and again a plus c. Remember, just for nicety's sake, we're going to put the c's on the same side. So some of you are saying, like, do they cancel? Well, they're just constants, so one can be 5, one can be 3, but I'll move the constants over to one side. So negative 1 over 2, y to the negative 2. And actually, you know what I'm going to do? I'm going to make this neater. Instead of saying y to negative 2, I'll just put the y squared on the bottom. Negative 1 over 2y squared equals x squared over 2 minus 2x plus c. And it looks like we're kind of done, but this particular this problem actually asks for, if you notice, it says it wants a particular solution. So what we've just been finding in general, or what we've been finding is just a general solution, but we want a specific solution for this problem. And you can tell it's a specific solution because it gives us, in the original problem, an initial condition. So when I say I want an initial condition, or I want the particular solution, that means I have to solve for c also. In this particular solution, they give us the x coordinates and they give us the y coordinate, so I can solve for c. So going back to my problem, well, going back to my initial condition, it says x is 1 and y is negative 2. So all I'll do is I'll go back to my problem and plug in x as 1 and y as negative 2. So on the bottom, I'm going to get negative 2 squared, which is 4. 4 times 2 is 8. So negative 1, 8. X is 1, so 1 squared is 1, and I get half. Then I get a minus 2, and I get my plus c. Again, some of you will hate fractions or don't want to deal with fractions, so what I'm going to do is multiply it by the common denominator. So here I see an 8 on the bottom is the largest denominator, so I'm going to multiply everything by 8. Multiplying everything by 8, and if in case you forget what I'm doing, I'll write it out for you. If I multiply everything by 8, I get negative 1, I get 4, oops, negative 8, right? Oh. Multiply everything by 8, sorry. 4 minus 16 plus 8c. Then all this is just basic algebra. This 4 minus 6 becomes negative 12. And if I add negative 12 to the other side, I'm going to get, or if I add 12 to both sides, I'm going to get 11. And then to get c by itself, I'll divide both sides by 8. So c ends up being 11 over 8. So think of it this way, we're only halfway done. So I told you this is a very long process. So what I'm going to do is I'm going to put this back into the original point where I thought I finished the problem. So what I'm going to do is I will apply the 11/8 into that spot right there. And I'm gonna bleed into this next page, but you might not write as big as me, so you'll be okay. So I'm gonna write -1 over 2y squared equals x squared over 2 minus 2x plus 11 over 8. Alright, the reason why we're not done yet is because to find the solution, and I'm going to use what the instructions for the second problem, is I need to put it in the format y equals, and this is not in the format y equals yet. Okay. So the very first thing I'll do is, again, to get rid of the fractions, what I'm going to do is I'll multiply everything by 8 again. So on this side, if I multiply by 8, I'm going to get -4 over y squared. I'm going to get 4x squared. I'm going to get minus 16x, and I'm going to get plus 11. So all I did was multiply everything by 8, so I don't have to deal with the fractions. Now the problem is that I have y squared on the bottom, so what I'm going to do is I'm going to multiply everything by y squared, and that way y squared is not on the bottom. So multiply everything by y squared, I'm going to call this -4. And on this side, what I'm going to do is I'm just going to put the y squared on the side for now. So I'll multiply everything by y squared, and the reason why I didn't multiply the y squared is because eventually I'm going to get y by itself. Then what I'm going to do is I'm going to divide both sides by that parentheses. So if you see this parentheses right here, I want to get y by itself, so I'm going to divide it from both sides. So now it becomes, I'm sorry, I told you it's a long process, 4x squared minus 16x plus 11 equals y squared. And the very last step is to get y by itself. Since I have y squares, I need to square root both sides. So just for sake of time, your answer is going to be the square root, like so. And then this part over here just now becomes y. So how about this? I'll just do one problem with you guys today. We'll do more practice in class, but hopefully you guys understand the process. What I did was, going back to the problem, I separated the variables, I integrated both sides, I solved for c, and then I plugged it back into the original formula to get y by itself. So hope you understand it, and then we'll go over more of this in class. See you guys later.